5.6, inequalities in one triangle. Now, do you remember what inequalities are? Inequalities are things like less than, greater than, less than or equal to, greater than or equal to. Instead of saying that x equals 3, we say that x is greater than 3, or x is greater than or equal to 3. Inequalities simply give us a range of values instead of a single value. Range of values. The objective in this lesson is to use inequalities that deal with the angles and the sides of our triangle. So the first thing we need to talk about here is the comparison property of inequality. Comparison property says if A is equal to B plus C, and C is greater than 0, so C can't equal 0, and it has to be a positive number, then A is going to be bigger than B. A is greater than B. Now you can look through the proof here, but what this says is that if we have A and B, and we add something to B, and then we set these equal, that whatever B is has to be smaller than the value of A. So if A equals 10 and B plus C has to equal 10, then B has to be something like 9, and we add 1, or 7, and we add 3, or 2, and we add 8. So all this tells us is that if we have something that equals two something else's added together, if we have a whole that equals piece plus piece, those pieces are smaller than the whole. And if you look here, we use our addition property, okay? And so that's how that works. Now you'll understand this better when we start looking at it in our triangles. So our first corollary here, first theorem, is a corollary. Do you remember what corollary means? Corollary means it's an extension or a special case of. So this is the corollary to the triangle exterior angle theorem. And you remember what the triangle exterior angle theorem said? It said the measure of our exterior angle equals the sum of our two remote interior angles. The sum of the two remote interior angles. So if you look at our picture here, do you remember this picture? It said the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So this corollary says that the measure of our exterior angle is greater than the measure of each of the remote interior angles. So think about what we just talked about. We know that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So what that says is that the measure of angle 1 has to be greater than the measure of angle 2, and it has to be greater than the measure of angle 3. So that's pretty straightforward. Let's look at an application of this. We want to know, why is the measure of angle 2 greater than the measure of angle 3? Well, let's find angle 2. Here's angle 2. And where's angle 3? Angle 3 is up here. We want to know, why is 2 bigger than 3? Well, let's take a look at this. Let's break this down. Need a little more space here. Look what we have here. We have an isosceles triangle. And so what does the isosceles triangle theorem say? The isosceles triangle theorem says that our two base angles are congruent. So we know that angle 1 and angle 2 have the same measure by definition of congruence. So what is angle 1? Look here, if we redraw just this triangle that we're looking at, here is angle 1, here's angle 3, and here's angle 4. What is angle 1? Angle 1 is our exterior angle. And what is angle 3? Angle 3 is a remote interior angle. And the comparison property of inequalities says that angle 1 has to be bigger than angle 3 and 4. So that's our corollary to the exterior angle theorem, is your exterior angle has to be bigger than your two remote interior angles. So let's look at our proof here. There's our isosceles triangle theorem that says 1 and 2. This is definition of congruence. Isosceles triangle theorem says angle 1 is congruent to angle 2. And angle 1 is an exterior angle. So our corollary to the exterior angle theorem says that the measure of angle 1 has to be greater than the measure of angle 3. And so by substitution, right, because angle 1 and angle 2 are the same angle, then the measure of angle 2 has to be bigger than the measure of angle 3. All right, let's erase those and pause the video, and you can try the next one. All right, why is the measure of angle 5 greater than the measure of angle C? Well, we went over here and we found angle 5 and we found angle C. And if we look at this, we are looking at this big triangle here because angle 5 is the exterior angle of the big triangle. So I redrew it here, and it turns out that angle C is a remote interior angle, and so is angle 3. So our corollary of the exterior angle theorem says that the measure of angle 5 has to be greater than the measure of angle C. Okay, that's not too bad. You've just got to find the proper triangles. So says we can use the corollary to triangle exterior angle theorem to prove the next theorem. So let's take a look at this. Now this one doesn't have a name, so we have to write it out. What does this one say? It says, if two sides of a triangle are not congruent, so that means not isosceles and not equilateral. So two sides of our triangle are not congruent. Then what happens? The larger angle is opposite the longer side. So this says that the length of xz, this side, is greater than the length of xy, this side. So this side is our large side, and this side we'll call our small side. So that tells us that the measure of angle y, right here, is greater than the measure of angle z, right here. That's pretty straightforward. That's really pretty easy. You have a triangle, not isosceles, not equilateral. Your sides of your triangle are not congruent. Anybody remember what that's called? That's right, it's scalene. It says the biggest angle is opposite the biggest side. And also the smallest angle is opposite the smallest side, and the medium angle is opposite the medium side. So let's take a look at how this works. We have a triangular park, and the architect wants to place a bench at the corner with the largest angle. So which two streets form the largest angle? Well, let's take a look here. We have this side, Hollingsworth Road, that's 175 yards. We have this side, Valley Road, that's 120 yards. And we have MLK Boulevard here, that's 105 yards. So which side is our longest side? Well, that's 175. Which side is our medium side? Well, that would be Valley Road over here at 120. And which side is our smallest side? That's MLK Boulevard at 105 yards. So we want to find the largest angle. The largest angle is opposite the largest side. So our largest angle is going to be over here. And the two streets that make up the side of that angle are MLK Boulevard and Valley Road, form the largest angle. All right, pause the video and look at the next one. Okay, this one was pretty easy. We want to put a drinking fountain at the corner with the second largest angle. So that's our medium angle. Where's the medium angle? It's opposite of the medium side. So our medium side was Valley Road. So we go opposite of that, and that happens at Hollingsworth Road and MLK Boulevard, where those two intersect. So that was fun. Now our next theorem is just the converse of the theorem we just had. So what did the theorem we just have say? It said that the largest angle is opposite the longest side. So let's look at what this one says. If two angles are not congruent, so again, not isosceles, not equilateral, this is another scalene triangle, then the longer side is opposite the larger angle. So this is exactly, this is just the converse of what we just did. Let's look at our triangle here. It says the measure of angle A, so where's angle A? There's angle A, is greater than the measure of angle B. So what do we know? We know that the side opposite of angle A, there's the side opposite, this is our large angle, so this is our long side. And angle B is our small angle, so this is our small side. So we can say the length of segment BC is greater than the length of segment AC. So what we just did, only going the other direction. And you can read through the proof here if you would like to, but I know you believe me. So let's look at a problem using this. It says, which choice shows the sides of triangle TUV in order from shortest to longest? So what do we need? We need to look at our angles here. We have a 58 angle, a 62 angle, and oh no, what's our third angle? Well, how are we going to do that? We know that x plus 58 plus 62 is 180. That's our triangle angle sum theorem. So x plus 120, 120 equals 180 minus 120, x equals 60. So we know this top angle here is 60 degrees. So we need to locate our small, our medium, and our large angles. And if we go across, this is our small, this is our medium, and this is our large size. So small angle, go across to your shortest side. Medium angle, opposite there, opposite side goes to the medium side. And our biggest angle, opposite that is our biggest side, our longest side. So from shortest to longest, we start with TV. So that means that one doesn't work and that one doesn't work because we have to start with TV as our shortest here. And then we go TV to VU, and then UT is at the end. So it has to be, this one's correct because these two are in the wrong order. UV is our medium size. So small, medium, large. Okay, looks like you get to do one now. Pause the video. We'll talk about this in a minute. We were given a triangle and given the measures of two angles. We used the triangle angle sum theorem to find the measure of the third angle, being 26 degrees here. Angle X measures 26 degrees. And we are asked what is the shortest side. So the shortest side is opposite the smallest angle. Angle S is my smallest angle, so I go opposite. If I look across the triangle here to the opposite side, that means that segment OX is the shortest side because it is opposite the smallest angle. So those are fun. Pretty easy to do. All right. An important idea here, something that is going to follow us through triangles, and this is good stuff. 3 segments of a triangle, if they're going to form a triangle, their lengths have to be related in a certain way. So if we have a triangle here, we have a triangle, 2 of the sides measure 3 centimeters, 1 of the sides measures 5 centimeters, makes a nice triangle. But what happens if we have a side that measures 6 centimeters and the other 2 sides measure 2 centimeters? Well, this is like our poor little T-Rex triangle. Oh no, my arms are too short. Right? These 2 sides are never going to be able to meet. So we have a theorem about this. The sum of the smallest 2 lengths must be greater than your longest side. So let's look at our triangle inequality theorem. It says the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So we have 3 equations here because we have to look at all 3 sides. These 2 sides have to be longer than the third side. These 2 sides have to be longer than that third side. These 2 sides have to be longer than that third side. So let's look at this. We have the length of xy plus the length of yz is greater than the length of xz. Those are our 2 sides, first 2 sides there. The length of yz plus the length of xz is greater than that third side. The length of xz plus the length of xy is greater than the length of yz. So all 3 of these have to be used. Now I'll give you a hint here and we'll go through that when we're looking at our problem here. Can a triangle have sides with the given lengths? Explain. So we want to know, we have toothpicks that, I guess they're not toothpicks, we have boards that are 3 feet, 7 feet, and 8 feet long. Can we make a triangle out of those? Well, the first thing we have to do is check that is 3 plus 7 greater than 8? Why, yes, 10 is greater than 8, so check. Is 7 plus 8 greater than 3? Why, yes, 15 is greater than 3, so check. And then we have to check our last 2 sides here. Is 3 plus 8 greater than 7? Why, yes, 11 is greater than 7. So all three work. So this will make a nice triangle. Now, the next thing that we have is 3 boards, a 10-foot board, a 5-foot board, and a 15-foot board. Can we make a triangle out of these? Hopefully you're looking and going, well, 5 plus 10 equals 15, and that is not what we're supposed to have here. It's supposed to be greater than 15. The little trick here is to pick your two smallest. Choose the two smallest values and check those first. So what are our two smallest values here? 5 and 10. Is 5 plus 10 greater than 15? No, they're not. So this will not make a triangle. What will happen here is we have something that's 15 feet long, and then, can you see it? This will be 10 feet long, and this will be 5 feet long, and they're just going to lay down and make two lines. So this will never ever make a triangle. All right, go ahead and pause the video and try the next two problems. The first problem said, can we have triangles with the given sides? So our first triangle has 2 meters, 6 meters, and 9 meter sides. Now, remember I told you start with the two shortest sides. That's the 2 and the 6. 2 plus 6 greater than 9. 8 is not greater than 9. This right here means you can stop and say no. I mean, if I did the rest of them here, you can look and see that 6 plus 9 is greater than 2, and 2 plus 9 is greater than 6, but that doesn't mean anything. This one no means no triangle. It's going to look something like that. Okay? So once you get a no, you're done. You don't have to go on and do those two. But I wanted to show you that they're true anyway. Now the next one, 4 yards, 6 yards, and 9 yards. Let's start with the two shortest pieces here. That one works out. So then it's just a matter of checking the others. 6 plus 9 greater than 4. 9 plus 4 is greater than 6. Yes, this will make a nice triangle. So these are pretty straightforward and easy. All triangles, the sum of two sides will always be greater than the third side. Sum of the lengths of two sides will always be greater than the length of the third side. This is true for every possible triangle. So if it's not true, not going to be a triangle. All right. Finding possible side lengths. We are going to mark this as a good example. We are given that two sides of our triangle are 5 feet long and 8 feet long. What are the possibilities for the third side? So let's draw a little picture here. And we know that this side is 5 feet, this side is 8 feet, and this side we don't know, so it is x feet long. So what are we going to do? Well, we are going to check, because remember, x is just a number. So let's do the first one here. We're going to check these two sides. X plus 5 has to be greater than 8. So x has to be greater than 3. The next two sides, 5 plus 8 has to be greater than x. So if this turns out to be 13 is greater than x. The rule for inequalities, if you switch sides, your inequality has to switch. So when we flip this around, up here the alligator is eating the 3, down here the alligator still has to be eating the 3. So x has to be less than 13. And our third set here, 8 plus x has to be greater than 5. So we subtract, we should probably go through this a little bit, right? These are just problems. These are just like it was an equals. A minus 5 is 3. We did that one. Subtract 8 from both sides. X has to be greater than negative 3. Can we have a negative length on our triangle? No, that doesn't work. We live in the 3 dimensions. So which two lengths are important to us? Being bigger than 3 and smaller than 13. So we can write it like that, but if you remember from algebra, we can put x in the middle, and x has to be less than 13, and if we switch this one around, 3 is less than x, right? We switch our inequality with it. We can put our small number on the left, our big number on the right, and our x in the middle, and these will always be less than. That means 3 is smaller than any possible x value, and x is smaller, any possible x value is smaller than 13. So x has to be bigger, greater than 3 feet, and less than 13 feet. So we could choose 4, we could choose 12, we could choose 5, we could choose 3.00001. It'd make a really flat triangle, but it would work because it's greater than the sum of the others. All right, go ahead and see if you can do the last problem. These look a little challenging, but they're not. Just make sure you use your 3 equations. So we were given a triangle that has side lengths of 4 inches, 7 inches, and we don't know what the third side is. We want to find out what are the possible lengths that it can be. And inequalities let us do a range of possible lengths. So I just drew my triangle, I labeled my sides, and I started out. I did x plus 4. I started with my 2 sides, doesn't matter which 2. X plus 4 has to be greater than the third side, which is 7. So I got x has to be bigger than 3. X is greater than 3. Did the next 2 sides. 4 plus 7 is greater than x. So x is greater than 11. I just switched those 2 around. X is less than 11. And then I did my last 2 sides. 7 plus x is greater than 4. And I got x equals negative 3. That answer doesn't make any sense to us, so it's not the one we're going to use. So I'm going to use these 2 answers here, and I know I can take this. 3 is my smallest number, so I know I can switch this inequality around to be 3 is less than x. Alligator's eating x in the original, so the alligator eats x in the switched one as well. So I know that 3 is less than x is less than 11. My third side of my triangle has to be greater than 3 inches and less than 11 inches. So this one looks like it's tough, but it really doesn't take that long, and it's really not that difficult. So I believe that you will have fun with the inequalities dealing with the sides of a triangle. Okay, good luck on the homework. I think these will be kind of entertaining. This is an entertaining way and entertaining and educational way to end Chapter 5.